Dear friends, today I'm very glad here to attend the International Fourth webinar of Cognitive and Behavioral Neuroscience Conference and share with my research. My title is A Mixing of Paper and Electronic Trial-Making Test for Cognitive Impairment with Automatic Analysis, Development and Validation Study. My name is Zhang. I came from China, Shanghai. My major is neurology. Okay, let's start. Firstly, I will introduce the background. As we know, computer-aided detection used in screening and diagnostic cognitive impairment becomes increasingly the focus of attention, which allows objective, ecologically valid and convenient assessment. Among that, sensor technology based on digital devices is potential method for detection. So our research was to develop and validate a novel trial-making test based on a mixing of paper and electronic devices. But with the development of artificial intelligence technology, many shortcomings of traditional assessment cognition can be overcome, and many research has found that the comprehensive assessment of cognition can reflect the patient's real states. Many studies are based on clock drawing tests and array complex figure tests to develop model, and the study based on TMT relatively scarce, but the TMT is a promising test for the representing the trajectory of cognitive decline. The aim of the study was to explore a mixing of paper and electronic TMT for cognitive impairment that provided an attempt to maximize similarities to traditional tests. We also developed an appropriate machine learning method to capture task-relevant features from recorded hand-painted trajectories and to evaluate the validity and effectiveness of the proposed framework for the detection of MCI and dementia, and compared its performance with conventional assessment methods. In this research, a community New sample of all the adults, 297 was included, classified of cognitively normal control, 100 patients diagnosed with mild cognitive impairment, MCI, 98 people, or Alzheimer's disease, 99 patients. We used an electromagnetic tablet to record each participant's hand-painted strokes. Meanwhile, a sheet of A4 paper was placed on top of the tablet to keep the traditional interaction style for subjects who are not familiar or comfortable with electronic devices, example, touchscreen. Furthermore, we developed an efficient and interpretable cognitive impairment screen model to automated analyze cognitive impairment level, which was dependent on demographic, time-related, pressure-related, jerk-related, and template-related features. Among that, The novel template-based features were based on vector quantization algorithm. Firstly, the model singled out a candidate trajectory as the standard answer from the normal group. Then the distance between the recorded trajectories and the reference was computed as the important evaluation index. To verify the effectiveness of our method, we compared the performance of well-trained machine learning model using the extracted evaluation index with conventional demographic characters and time-related features. In addition, the well-trained model also was validated on follow-up data, normal group 38, MCI 32, and AD 22. This is a protocol. We can see the figure shows that the mixing of paper and electronic TMT is composed of an A4 paper and an electromagnetic tablet. Participants perform the TMT using a digital pen, and the electromagnetic tablet connects the trajectory and pressure. Then the automatic analyzing program extracts tablet collects the trajectory and pressure. The automatic analyzing program extracts highly related features to break these functions to provide help for diagnosis. There are 4 steps. The first, drawing data. Second, collecting the trajectory and pressure. 3, feature construction and loss diagnosis. The figure shows the workflow of template-based feature extracting. Firstly, calculate inter-trajectory DTWD with normal control group and pick out the trajectory that has minimal average DTWD on the template. Secondly, perform clustering and vector quantization to extract key points of the template and or other trajectories. Finally, compare each trajectory with the template to obtain template-based features. We can see the DTWD between 2 trajectories, distance between corresponding key points with relatively weighting, distance between corresponding key points without weighting. These are the results. The prediction performance comparison of 4 machine learning algorithms support vector classification, adaptive boosting, random forest, gradient boosting, decision tree, light gradient boosting machine. We can see both machine learning algorithms have excellent accuracy and AUC. The next results, the diagnostic performance of random forest model based on conventional features or all features. We can see the accuracy, AUC, sensitivity, and specificity both plays good, both performs good. The figure shows the importance of features to the diagnosis of brain dysfunction based on the random forest classifier, as we can see. The fifth important feature is DTWD completion time, VQ without weight of test A and test B, and test B is the most important. By analyzing 389 subjects, we developed and validated a novel mixing model of paper and electronic TMT, which not only kept on the traditional interaction style for subjects who are not familiar or comfortable with electronic presentment, but also offered both reproducible and abundant information for automated cognitive assessment. Furthermore, we can get excellent classification accuracy. Meanwhile, we also validated our model in the volume of subjects, and the accuracy also good, and we suggested that 4 types of associated features with cognitive decline. Experimental results demonstrated its effectiveness in enhance the accuracy of screening for cognitive impairment. Last, with the conclusions, we proposed a novel mixing model of paper and electronic TMT, which was expected to not only retain the traditional interaction style for subjects who are not familiar or comfortable with electronic presentment, but also offer abundant information for automated cognitive assessment. Meanwhile, we also suggested 4 types of associated features with cognitive decline for screening. The results demonstrated its effectiveness and show that the proposed method may contribute to the development of a practical tool to help ascertain the patients of normal cognition in the clinical environment. That's all. Thank you. This is our team. Thank you for your listening.